Hi, welcome to my webcast on Cisco's One Platform Kit, or onePK. My name is Joel Knight. I'm a systems engineer with Cisco, working with energy companies in Western Canada. My blog is www.packetmischief.ca, and you can find me on Twitter at Knight_Joel. So I recently had a chance to get my hands dirty with onePK in the lab, and it really made it clear to me what onePK is and how it will change the way we interact with network elements and with the network as a whole. So since the impact of onePK is more strongly felt with a visual demonstration, I decided to make this a webcast so that I could show some of the examples of how onePK can be used. So just a quick disclaimer, even though I do work for Cisco, this is not an official Cisco blog post. This post is hosted on my personal blog, and as such, the opinions expressed in this video and the associated blog post are my own and not necessarily those of Cisco. So before we get to the demo, let's just talk about what onePK is. So onePK is the One Platform Kit, and it's a foundational part of Cisco's open network environment, or Cisco One. And what onePK does is it addresses the programmability aspect of software-defined networking within the Cisco ecosystem. So as the quotes here explain, onePK allows for the development, automation, and rapid service creation within the network. And really what onePK is it's a set of APIs and a software development kit that allow third-party applications to talk to network elements, Cisco network elements running iOS. And one thing I really want to highlight is that onePK enables far more than just programming forwarding tables and packet forwarding. Think of it really as an extension of iOS. So we can do things like look at not only the data path, which is certainly there, it's a capability, but we can look at things like routing adjacencies, routing protocols, protocol change events, things like neighbors going up and down, that sort of thing. We can do discovery, so network element discovery, topology discovery. We can query information about network elements, such as location and interface information, configuration management, and we can also configure and query other aspects of that network element, such as AAA configuration, syslog information, DHCP services, NetFlow, that sort of thing. So the third-party application that leverages onePK can really extend the capabilities of iOS by hooking into the logic that's already in iOS and bringing in outside logic such as maybe business processes or processes that exist within the IT group and loading that kind of logic into the application, which can then orchestrate and program and automate the network as a whole. So I wrote a companion blog post to this titled Cisco onePK, Now I Get It. And I wrote this after I first was exposed to onePK in the lab, and it kind of opened my eyes to the potential for onePK and what onePK really is all about. So I encourage you to read that. It gives a good overview of what onePK is and actually relates it to a very common open source project that a lot of people are familiar with. So unfortunately, at the time of this recording, I don't have the exact URL for that blog post as it's not actually published yet. But if you head to packetmischief.ca/tag/onePK and just look for the article with that title, you should be able to find it. Okay, so an overview of what this demo is going to look like. So I'm going to demo two applications. The first is called the MTU checker. And what this thing will do is it queries the network and looks specifically at the MTU on all of the routed interfaces in the network. And it will either flag the link when there's an MTU mismatch on either end, or we can even have the app take corrective action. And we'll show that in the demo here. And the second app is called Routing for Dollars. And this one we're demonstrating the programming of the forwarding plane in the router but we're programming the forwarding plane based on business logic and business metrics, specifically the cost in terms of dollars for using one link versus another. So we'll demonstrate that here. Just want to point out the demo network here is running iOS, and it's onePK enabled, and this is all real software. There's no scripting here. There's nothing kind of automated. This is happening real as I'm demonstrating it. So let's get into the demo here now. Okay, so here's my demo network. We've got 3 routers here, 3 network elements in the network. And so this window here on the left is actually the application. This is the MTU checker application. When this application loads, which I haven't shown in the video here, but when the application loads, it's been told which device to use as a seed device. I believe it's this guy here. So it'll log into that device and do a neighbor discovery and basically spider out through the network and dynamically discover the topology. As well as you can see here, it's indicated which interface is connected to which neighbor. So it figures all that out dynamically and then plots this topology within the application window here. The terminal window on the right hand side here, this is a console session into the router in building 1. And this is the one we're going to use to demonstrate what happens when the MTU changes on the router. So we can see right now all the links are green. This indicates that we have MTUs matching on both sides for all of these links. And we can further prove that by, again, just mousing over and looking at the interfaces here. We can see interface 2.0 on the router is 1500 MTU and 1500 on the neighbor 2.0 as well. And same with serial 2.3 to serial 2.3. Another thing I'll just point out quickly is the application has the different modes here. So right now we're in the reporting only mode. So we're going to do this first, and we're going to see how the application is able to detect in near real time when the MTU changes and when we have a mismatch. And then after that, we'll do an auto fix, and we'll see that the application is able to take corrective action immediately without having to, without relying on an operator, a network operator, to notice that there has been a change in status and taking that remedial action manually. So if we go on the router here, and we'll just change this MTU to something different than the 1500 that it's set to. And we can see that immediately the application picks that up and flags the link as being read. So one thing that really struck me when I first saw this demo is that the communication between the network and the application through onePK is two-way. When I think of things like OpenFlow and network programmability, the talk always seems to be about information and commands going from a controller to the network. It's very one-way communication. But with onePK, what we have is the ability for the application to request notification when certain events are triggered or certain things happen on a network element. And in this case, this application has requested a callback whenever someone issues the MTU command on an interface. So by running that command here on the building 1 router, I've actually triggered that callback into the MTU application, and it receives this value of 1400 and checks that against the MTU value of the neighbor. So the communication, the data flow here is really bidirectional. The network signaled to the application, hey, this event happened, and that allowed the application to take some action. And I think that's pretty cool and also extremely powerful. Imagine looking at things like routing protocol adjacency changes and having your application be notified as soon as that adjacency change happens. Now, in the past, I mean, we can kind of get that information today through either syslog messages or even SNMP traps, but that's going into, a syslog collector or an NMS system of some sort. We don't really have the ability to take corrective action from that. At best, we might be able to fire off some sort of script or something that might hit the network element and do some commands, but it's very tricky and it's very rough, and it has to really be almost homegrown and hacked together. This, through onePK, provides a common interface, a common API across various iOS flavors, across NXOS, and across any hardware platform. So the action that the application takes is really built to the API, and it's not built to, okay, I have this ASR in the network, I have to do these specific commands to the ASR, I have to do this to the Nexus, I have to do this to the CRS. The application doesn't have to care what the underlying hardware is, it just leverages the onePK API and can take whatever action it needs to take. So also just take a look here. If we mouse over, we can see serial 20 is now recognized as having an MTU of 1400 connected to 20 on the neighbor, which has an MTU of 1500. And we got the little asterisk there indicating that that is the link that's got issues, or the link that's showing red right now. So if we set this back, see the link goes green. Again, we get that callback. The application is informed that the MTU has changed and the MTU is matched now, so we're all good. Now let's set this to auto fix, and let's just go the smallest value, and then I will set this back to 1400. And before I do that, just to confirm, so we're 1500 on both sides. We'll set building 1 router to 1400. Now we're not going to see this link actually flash red, because instead of showing us that there's a mismatch, as soon as that callback is fired, the router sees there's a mismatch, the application sees there's a mismatch and will automatically correct the far end link. So if we mouse over, we can see now both links are set to 1400 and we're all good. So this is a great example of an application that has nothing to do with the forwarding plane. We're not looking at forwarding packets or flows or anything like that. We're simply programming the network and receiving information from the network and then taking corrective action via programming the network elements. An application like this would be of high use to a network operations team, and especially in the corrective action kind of mode. Imagine the application taking that corrective action and setting the MTUs so that they match, thereby avoiding any kind of impact to services running across that network link. And then imagine it also firing off an alert to the operations team so that they're informed that A, a change was made to the MTU, and B, that the application remediated it automatically. So the second application I wanted to demonstrate was the routing for dollars application. What this application does is, again, it models the network in a nice visual map here. And it allows us to exert control over the forwarding plane of the Atlanta branch router in this example. So this network is running EIGRP right now, and it's relying on EIGRP's metrics and best path determination mechanisms to control forwarding of traffic and determine which of the links, either the left or the right, is used to get from the Atlanta branch to the cloud service. And right now, EIGRP has decided that the right-hand link is the best path. And what this application allows us to do is inject some business metrics into that best path determination and really send traffic around the network based on what makes the most business sense versus a purely technical sense. So whereas the business might not care as much about bandwidth and delay and those sorts of things, they might care about the cost of a link. And that's what the dollars in this routing for dollars app is all about, is we're looking at the dollar cost for using the link on the left versus the link on the right. So right now, this application is in a mode where it's strictly using the routing table. It's using the traditional technical metrics, I'll call them, to make that best path determination. And what we can do is we can flip that to using our business metrics by changing this option. And the application will then program the forwarding plane on the branch router based on the metrics that the business metrics that we feed into the application. Before I do that though, we'll just do a quick verification that the topology that's been modeled here is actually reflected in the branch router. So we'll run a quick trace route, and we can see from Atlanta here, the first hop towards the cloud service, which is 100.111. The first hop is 40.10.1.2. This is the 40.10.1 network on the right-hand link, and .2 is the RTP router. So that looks good. The other thing we can do is actually hop onto the Atlanta router console and take a look at the forwarding table. So 40.10.1.2 matches our trace route, all good. And if we do show IP route and we take a look at that cloud service IP address, we can see that this route, this prefix is learned via EIGRP. It's just a regular EIGRP route. So now let's feed some metrics into this app. So we're going to set this link to $3 and this one to 2. Now notice nothing changes right now. We're still using the regular technical metrics, the regular EIGRP metrics. So we're not going to have a topology change. What we need to do is we'll flip the application over to using our business metrics. And after a brief reconvergence, we now have traffic flowing over the left-hand link. We can verify that with another trace route. And from Atlanta, we'll see the first hop is now 40.21.2, which is taking the left-hand link. So the topology looks good there. We'll also get over on the router, take a look here, 40.21.2, that matches, it's all good. But now if we look at the route for the cloud IP prefix, we can see that this is quite different than how it looked before. This route has now been injected via an application, the routing for dollars application. So this is no longer an EIGRP route. This is a route that has been programmed through the onePK interface by this application to exert control over where traffic is moving in the network. Just to take another look at it, we can see here at the very bottom, the 100.110 network is denoted by the lowercase a, and that, as the legend shows, is an application route. So kind of a little sneak look there. It's a new kind of route type, if you will, that will show up in iOS. So the other thing we can do now, if we exert some influence over the metrics that we fed into the application, so we'll set this right-hand link from $3 down to $1. And again, after some brief reconvergence, the application will adjust the route that it's programmed into the network element. And we can see here, still known by the routing for dollars application, but we have a new next hop here back to the 40.10.1.2, which is on the right-hand link. Now the other thing we can do, if we influence the topology of the network from the network element. So what we've done so far is we've strictly manipulated the topology through the application by changing the mode of the application from using the technical metrics to using the business metrics. and also by adjusting those business metrics. So we move from the left-hand link over to the right-hand link. Now what we'll do is we'll simulate an event in the network that will cause a topology change. So all I'm going to do is shut down this right-hand link, and we'll see that again we have a really good example of the bidirectional communication that's possible with an application that's written to onePK. So the network here, specifically the Atlanta branch router, has signaled to the application that there's been a forwarding topology change. The application then recalculates the topology and indicates that even though the metrics indicate traffic should be on the right-hand link, obviously that link is down, it's out of service, traffic is now flowing on the left-hand link. And if we restore that link, we'll see traffic return as well. And there we go. Okay, so just a couple of key points here that I want to highlight. Number one is that onePK is about more than just programming of forwarding table entries. A lot of buzz and hype around SDN right now has to do with programming flows through the network and orchestrating traffic and tunnels and overlays and whatnot. That's all good and that's all fine, but the capabilities within onePK, or the onePK exposes, goes far beyond forwarding tables and programming flows. And the demonstration of that is really the MTU checker application, where we weren't looking at flows or forwarding tables or routing entries or anything like that. We're looking strictly at actually interfaces in that case, and a particular configuration property of those interfaces. And that's just an example of the kind of information that we can glean out of onePK. Obviously, the second demo that I did with the routing for dollars, clearly we were looking at programming flows and forwarding table entries in the network there. And that is certainly a capability within onePK, so that's not lost. But onePK goes beyond just forwarding tables and enables rich orchestration and programming and management of network elements running iOS and XOS. Point number two is one of the bigger ones to me that really hit me when I was first working with this in the lab, and that is that communication between apps and the network is bidirectional. So not only can the application signal to a network element to take some action or implement some sort of config, but the network element and the network can send data and events back into the application. And the example of that is really the MTU checker application, where that application brings up the topology map. And that map is really read-only. We don't do any programming or orchestration of the network through the app. The app is just listening. It's listening for those MTU change events being signaled from the network, and it then takes some action. I think that's really powerful. Imagine, again, looking at routing protocol adjacency changes, or maybe looking at traffic level changes, that sort of thing, and being able to take intelligent action based on those events. Point number three is something that I think needs clarity amongst some people that are looking at SDN and have this belief that the applications that we talk about in the context of SDN are really the enterprise and line of business type apps, things like Exchange and SAP, web services, stuff like that. I think the clarification needs to be made that yeah, it's it's likely or possible one day those types of applications will leverage the programmability that's exposed in the network through things like onePK. But I don't think anybody expects those kinds of apps to have that capability on day one. But I think the problem is that people are writing off SDN and writing off network programmability because of the belief and understanding that those enterprise applications will not have the capability to leverage network programming APIs on day one. But I think if that's the case and people are writing off network programmability because of that, that they're missing a huge opportunity and a huge area of value. And that would be with the IT operations folks, the IT departments, the DevOps folks who could really leverage programmability in the network with their own homegrown tools, homegrown scripts. And I feel like the two applications that I demonstrated here would be highly useful to an IT operations group and a good example of how we could immediately extract value out of the programmability that is being exposed through the network. So these are not line of business apps. You wouldn't have an end user ever looking at any of these tools, but they help the IT department manage, monitor the network. And in doing so, they are helping the end users, the customers, the business that is depending on the network. So I think that's a huge opportunity, and something that I'm really excited to see actually is what kind of applications and apps people will develop to help just manage and monitor the infrastructure. So point number 4, and I apologize because I can't remember who made this analogy, but it was something I heard someone say in a presentation on onePK, and it really stuck with me, and I think it does a really good job of illustrating the potential for network programmability and what onePK is enabling. So the analogy was that Cisco One and onePK are really turning the network into a platform on top of which applications such as the MTU checker and routing for dollars can sit. The comparison is that this platform is a lot like what Apple did with their iOS and the iPhone. So they created a platform on top of which they themselves, as well as third parties, could create applications and host applications. Now, the platform on its own is of little to no value. So if I handed you an iPhone today, it had the latest iOS on it, it had all the same APIs in it that it does today, but it had no apps on it. That thing would be completely useless to you. The value that we extract from the platform is only realized through the apps that sit on top of that platform. So if I hand you that iPhone and it has Safari on it and the mail client and the Facebook app and Evernote and so on, now there's value in that tool. It's a whole system now, and you can leverage it to get things done and be productive and so on. And onePK is going to be the same. So Cisco One and onePK are going to turn the network into a platform. That platform on its own doesn't do a whole lot more than it does today. It moves bits back and forth and whatnot. The value is going to come from the apps that sit on top of it. And going back to number 3 here, this is not just or not necessarily the enterprise apps, but this is the apps that Cisco potentially, Cisco partners potentially, and certainly third parties will develop to sit on top of this platform and extract value from the information that is exposed through onePK and the programming and orchestration that can be done in the network through onePK as well. And I think that's really exciting. So I think if you rewind the clock and look back a few years before the iPhone and before Android existed, and you tried to imagine what the world would be like today in the mobile space before we had firsthand knowledge of these platforms and what they're capable of. We really had no idea. And now today we take them almost for granted. And these devices and operating systems as a platform really enable almost anything you want to do. It's really quite amazing. And I think the same thing is going to happen in the network. So we're going to have this platform, and if we can look out kind of around the corner a few years to when we start seeing applications start to be written on top of this platform, it's going to completely change how we do networking and how we interact with the network, how we manage the network, and perhaps most importantly, how the network is able to deliver services to end users and customers and to the businesses that these networks all serve. So with that, I want to thank you for watching. I hope you found this interesting and at least somewhat educational. I'd love to hear from you. If you want to get in touch, you can leave a comment on the blog at packetmischief.ca or send me a tweet at knight_Joel. I look forward to hearing from you, and we'll see you again next time. Thanks for watching.